Hello, everyone. My name is Brandon Evans. I'm a certified instructor at SANS. Here I'm joined with Eric Johnson, a senior instructor here at SANS. And today we're going to have a nice little casual webcast where we're going to talk about some of the interesting experiences Eric has had working as a consultant, a cloud security architect, engineer, and analyst. And I'll be here to ask him some questions, talk about the issues that he's dealt with, and discuss solutions, as well as forward along your questions in the comments. So keep those coming. Before we even get started, I know what everybody's question is going to be. Brandon, why do you have an enterprise-grade Dance Dance Revolution mat in your background? That's just what I'm into. So got that out of the way. Now we can focus on security. And without further ado, I'm going to kick it off to Eric, and we're going to start talking about a very interesting war story that he's had, the IAM Menace.
I love the title. The intro song got me kind of fired up for this. So very exciting stuff here. And Brandon, you're going to dance at some point, right? As we kind of like end the session and they turn the music back on.
Sure, if popular demand requires it.
Right on. Let's see. So this is let's just call it, we'll call it Tabletop Wednesday, I guess. We're off by a day here. But I put together a little scenario that's probably the combination of a few different things that I've seen in real life out in the wild lately. And I wanted to just walk through a use case of here's a system and it's got some hybrid cloud connectivity, and then talk through some things that we found from more of a red team approach that you could do with the system. And then I'm going to kind of let you all and Brandon ask questions, and then together we can maybe go through some defensive techniques that maybe could have been in place in order to make this a little bit more secure from the ecosystem perspective. So let's put a little diagram up on the screen here. Let's see. Are we seeing that, or do I need to read? Oh, there we go. Beautiful. So here's your scenario. Now, this really could have been in any cloud out there. I selected GCP because a lot of the work that we've been doing with my company, Puma Security, lately has been inside of the GCP platform, which I think speaks to how quickly that company is growing, at least that cloud provider is growing. And then big news this week with the Mandiant acquisition as well. So I'm very curious about how that's going to play out. Maybe we can sidebar on that later. But let's start with at least a pretty common scenario in a hybrid cloud environment. So in this scenario, pretend that you're either hired to do a pen test on this internal server. So on the left-hand side of this diagram, we've got our on-prem section of this thing. So that's normal on-premise, your corporate environment. There's users on-prem, and they're connecting to a server. And that server is running some software. So I think, in this case, it was a Java application, but it really could be anything, any sort of Node app or whatever that the users are interacting with, right? They've got some APIs, there's a user interface on it. And when they enter some information, that server needs to authenticate to an API gateway that's sitting out there inside of GCP, AWS, Azure, whatever. The way that authentication is working in this scenario, and this is GCP specific, is that there's a service account that's been created inside of GCP, and that service account has a key associated with it. So the service account key file is essentially public-private key pair. It allows you to authenticate to the API gateway and invoke some APIs. Now, behind the API gateway is App Engine. So there's some kind of dual App Engine redundant servers running in a VPC. And those App Engine services are communicating with your standard backend storage, right? So you got cloud storage, you got a little SQL database for storing data, et cetera, et cetera. Let me pause there for a moment. Does the scenario makes sense. Brandon, any questions or thoughts as we just look at the normal use case scenario and what this thing is supposed to be doing?
So far, so good. Looking forward to asking some questions once we talk about the attack, about how we could potentially architect this a little bit better.
Yeah, for sure. It's it's interesting. So every pen test you do, or I guess if you're just truly an attacker, you never quite know where this thing is going to lead you to, right? So in this scenario, this is a Windows box. So we get essentially granted remote desktop access to this Windows machine, and they say, find what you can find. Where do you start? So the first thing we do, okay, there's a Windows service that's running. There's also the web app, the website that's running, I think, or the JVM in this case, right? So we're hosting this just through some sort of web server on Windows, and we go look and see where that's installed at. And you find some jar files. So has anybody reverse engineered jar files before? Nobody would ever do that, right? There's some pretty very basic open source tools, like Jar Explorer and things like that. Brandon, any experiences doing that?
I wouldn't even call it reverse engineering. It's just decompilation. I mean, it's really easy to get access to the original source code in a jar file that hasn't been obfuscated. So if you're not putting in that extra work, you don't even have to do the reverse engineering.
Yeah, I mean, it's really just reading code. I mean, it comes back almost the same as it was compiled to you. So we open up the jar files, we start looking at code, we look at the config files, and eventually you land yourself in this method or this function, whatever you want to call it, that is authenticating to Google Cloud. So you knew it was happening because we kind of had some inside info from the customer. Hey, this is talking to a Google Cloud project. And the first thing you're wondering is, okay, how are we authenticating? And you find the code that is looking on the file system in a specific location for one of these service account key files, the JSON file. And that's ultimately what you're after, right? Because I don't care what the application is going to do. I just want to kind of get the app out of the way and then authenticate directly to the cloud using that key file. So we test the API gateway stuff out there. Really, to be honest, wasn't a lot of fun to be had with just the APIs and the API gateway. And this is where the title of our discussion today comes into play, the IAM Menace. So at this point, as we all know that have worked in cloud world for a while, IAM permissions are hard. It's very difficult to scope things to an appropriate, let's just say, access control level from a resource perspective. Is the API gateway service account key able to talk to GCS bucket 1, GCS bucket 2, GCS bucket 3, or all of them as you build these roles and these policies out? So the first thing we did was kind of just run the gsutil ls command on all of the storage buckets using that service account key from the machine. And you get a big list of GCS buckets back. So now you know the service account role has kind of the full read, at least, list permission. And we ultimately found out it was a read permission, right? The storage object reader role on all of the GCS buckets inside of this project. So that could be bad. It could be normal. Who knows at that point, right? So it's all about what's in the buckets. The names usually kind of give this away, right? So we see the system name. Let's just say that's the API gateway bucket sitting there. That seems like that would be something it probably should have access to. Okay, so that's normal. But then you look a little further and you start to see some buckets related to CICD operations. So there's a bucket basically called, continuous delivery application, something like that. Okay, that looks interesting. I wonder what could be in there. And then you see another bucket related to CICD Terraform state. And you think to yourself, oh, that's also very interesting. I wonder what could be in that. And let's just pause there. So where do you think we're at this point, Brandon? You think we found anything interesting just by evaluating storage permissions?
Quite a bit. The first question that I have for you is, why would there ever be a key file on this application server that gave the application server direct access to the storage buckets or the secrets manager? Couldn't that be interfaced via, let's say, some kind of cloud virtual machine or via the API gateway? Why is this key file that seems to be just used to interact with the API having all these different permissions?
Great question. It kind of gets into the IAM problem, right? IAM it's difficult. Now there is some, we'll maybe talk blue team here in a little bit. There's easy ways to identify, I would call this an over-permissioned system in a sense. If everything's supposed to come in through the API gateway, and that's supposed to be, if you want to think of it as your proxy almost, right? Requests to talk to storage should have to go through the API gateway to get to said storage and retrieve an object back. This isn't really an issue if we've got it set up that way. But for who knows what reasons, right? IAM just wasn't really set up correctly to begin with. So I don't have a good answer for you as to why, except from the red team perspective, this is awesome if we're wanting to exfiltrate and break into things.
Awesome. Well, I have a lot of other questions that I'm going to save for the end because I don't want to get too deep in the weeds from a blue team perspective. The only other question I have for you, which hopefully will tee up this next section, is what kind of data do you typically see in a Terraform state file? What kinds of things end up in such a file?
Yeah, so the next pivot in the conversation is, well, let's look inside of this thing, right? We want to see, maybe we only have the list bucket permission. Maybe we can't actually read data from these other ones, which is pretty common, especially over in the AWS ecosystem. Usually you kind of need the list bucket permission in a lot of cases to check for access control levels before you actually read and write from the bucket. So just because you know of its existence or the name of a bucket like this doesn't necessarily mean it's bad. It was in this case. So the CICD bucket, could be interesting. There was a lot of deployment artifacts and packages in there, but not really any source code or anything that we already didn't have on the RDP session itself. Those were just, think of the zip file for the Java app, the war file, whatever it's called, the ear file. And then that's getting pushed onto the server in some fashion. So nothing really exciting in there. The Terraform file is pretty interesting. So for those of you that don't use Terraform day in and day out, the way that Terraform works, it's a declarative language, HashiCorp's language, HCL, that essentially allows you to programmatically build your cloud. So if I was going to create let's just say that API gateway GCS bucket, I would go grab that resource and say, I want a GCS bucket. You set the properties, name, ID, etc. And then you run the Terraform plan, Terraform apply command. And when you do that, Terraform uses what's known as a state file to keep track of all the resources that it's managing. And by default, that file is stored locally on your machine that you're running these commands from, which isn't very good if you accidentally blow that VM away, or if it's in a Docker container and the state file is gone when it's done and running. You kind of need that state file to know what work you've done in the past. So typically you store that remotely somewhere. And normally you're storing it in storage for the cloud provider that you're managing. So it makes perfect sense that there was a Terraform state file, for managing this entire ecosystem. The problem that I saw is, one, and this goes into like GCP security best practices. If you go read through kind of GCP's secure architecture guides, they will say, don't store all of these things in one GCP project. So there should have been kind of a CICD Terraform project out here in DevOps land, storing the state file, and then that's managing the resources over in the primary workloads, the API gateway project. So there's a little bit of architecture that could have been maybe done a little bit better up front, but it wasn't. So what's in the state file? The TF state files really have a blueprint to your entire cloud. If you're managing 100% of the resources in Terraform, every resource and every attribute of that resource will be stored in the state file, because that's how Terraform keeps track of all the things that it's created, the configurations, etc. And going back to your question, Brandon, what did we find in there? Well, I didn't know that there were secrets in the secrets manager until I read the state file and said, oh, cool. There's also secrets manager secrets that are being managed by Terraform, which kind of leads you to the next pivot.
Awesome. Now, you mentioned in this case that allowed you to identify that secrets existed in this account. Can the Terraform state file itself contain secrets?
Oh, for sure. It had all of them. I didn't even have to really talk to the secrets manager, because the secrets manager secrets versions, which is, individual actual values that are attached to these things, were also being managed by Terraform. So we confirmed that they matched up. We talked to the secrets manager later to validate it, but what we found in the secrets manager were actually more service account keys outside of the one that we had on the Windows machine over on-prem. Now from the Terraform state file, suddenly we've seen new service account keys. One of them actually was the CICD service account key that was being used by like a GitLab Kubernetes cluster that's over kind of outside of our scope. And what kind of permissions do you think were attached to the CICD service account?
Oh, the CICD service account. I mean, what all could that even do, right? I mean, there's no way that you'd manage your entire cloud infrastructure via one of these tools, right?
Yeah, I mean, it's only the service account responsible for creating, updating, and destroying all of the resources in the project. Those don't have powerful permissions at all, right? Hopefully you all are sensing my sarcasm here a little bit. It basically has an owner on the project, because its job is to stand it up, manage it, and spin it down or destroy it when it's all done. So we've now gone from this tiny little API gateway service account key file all the way up to pretty much pwning the entire project, which is, I'd say you've won at this point, right? So let's pause here for a minute, and we can maybe take some questions from the audience if there's any coming in. I don't think I'm seeing any on my end. Brandon, feel free to fire away. What do you think about our situation that we're in up to this point?
So maybe getting a little bit ahead of myself, but I think it may be valuable to the folks in the audience. Not everyone is necessarily familiar with continuous integration and continuous deployment pipelines, otherwise known as CI/CD. Now, for all of the philosophy nerds in the audience today, I like to compare CI/CD to the Leviathan, this mythical creature that you give all of these permissions to so that it can do these horrible things on your behalf, and that no individual has all that power. You've vested all that power in this external entity. But there has to be a better way than just giving your CI/CD pipeline admin access to all of your cloud accounts, right? What are some ways that we can limit the power of this extremely powerful system?
Yeah, it's hard. We'll start with that, because as we mentioned, it truly does need full create, update, and delete permissions on at least some resources, whatever it is that you're managing. So I think in Magno, I saw asked out in the in the chat channel, he asked, are there any tools or recommendations to check for IAM permissions inside of GCP? So kind of going down that same path, right? How do we know if one of these service accounts is over permissioned based on its activity? And what you can do is GCP has a tool called the IAM recommender. And it's very similar. AWS, I believe, also has one of these. I think it's called IAM Access Analyzer, I want to say, where you can turn it on. And what it does is it will look at the permissions attached to, let's just say, the CICD service account. So you've got this service account role. Let's just say we gave it owner, which is a big no-no. That's kind of the easy way out, right? I don't want to deal with permissions. I'm just going to throw owner on it so I don't have to ever check this again. And IAM Access Analyzer will look at what the service account is actually doing, what permissions it needs, and compare it to the permissions that it has. And if you go into that section of the GCP project, it'll actually have this little red icon on it to say, hey, there's over permissioned roles or what have you on this particular service account. You should check this thing out. And it's pretty cool. You can click on it, open up the CICD service account, and it gives you this matrix. It says, here's the permissions based on the cloud audit logs, the activity that this thing has performed. Here's what it's done. And here's the permissions that it has. And it actually says you can remove these permissions and just keep these to scope this thing down to what it needs to perform its functional tasks. So maybe, for example, the service account needs access to storage, secrets, API gateway, App Engine, VPC networks, and the other bits that I'm showing you on the slide. That's assumed, right? It's going to probably need admin access to those services. But then you look at the rest of the APIs and the rest of the ecosystem, we probably don't need access to, the big data services. Maybe there's no cloud functions. Maybe there's no security command center or IAM type operations that this service account needs access to. So you could start to scope things down by service. And I think that's probably the most granular you can get with a CICD service account in general, since the underlying premise, as you mentioned, is giving it lots of permissions to do work for you as a system admin, essentially.
Absolutely. I think another part of it is separating your resources into different projects or different accounts. Now, Rich actually in the comments mentioned something related to that. He mentions that Access Analyzer is good, but it's really only good on a per account basis. There's no cross account or trust boundaries analyzing. Do you have any experience with overcoming that deficiency that Rich mentions?
Yeah, I haven't seen a holistic view, let's just say org-wide view of that data really either. So to get it, and this is going to be the DevOps person in me coming out here with the response to this, but when a cloud provider doesn't do something that I want it to do, typically it means I've got to write some scripts or some code to call a bunch of APIs on my own, aggregate all of the data and put it into my own dashboard. So that's not something I've done, but I think could probably pretty quickly be done, iterating over all of the accounts in the orgs and grabbing that data through the API. And then we just have to figure out how to display it. I'm sure that there are also third parties such as, Wiz and Orca and folks like that have probably tackled this problem, and they've got some really good dashboards, and maybe they give you a better view of kind of what those org-wide permissions might look like.
So I have one more question before we continue on to your analysis. And then there's also one question in the chat that I'd like to address. But I know where we're going in this conversation, where the service account associated with CICD has a lot of permissions that it doesn't need. You've also alluded to the fact that perhaps the application server's permissions are overly powerful. My follow-up question is, did you find that the service account associated with the application server, were you able to create resources using that set of permissions? Like, for example, could the application server launch a new virtual machine itself? And if that is the case, what could an attacker do with that capability?
Yeah, good question. I mean, in this scenario, there were no write operations really allowed by the app server one. So there was essentially an authenticate to the API gateway, and then it was really just storage reader and secrets manager, secrets accessor, I think is the name of that particular role inside of GCP. So nothing truly super damaging outside of the pivot into the state file to get more secrets. And then eventually you knew the secrets were there as well. But we'll play your scenario out. If you could spin up a VM, then things get kind of interesting as well. And it kind of all comes down to that act as permission inside of GCP. So if you could spin a VM up and you have the act as permission, suddenly that's kind of a nice little privilege escalation path that I know Kat has talked about quite a bit just in her webcasts with SANS and at CloudSec Next last year. Kat did a great, Kat Traxler, for those that don't know Kat, she's a GCP kind of IAM wizard, I would say. Gave me a lot of my early on lessons inside of GCP, kind of on how these transitive kind of relationships works between service accounts and whatnot. But that service account, in theory, if it could create a VM and act as another service account, could attach a different service account to the VM, bring it to life. And then from there, you can connect to the VM, use the metadata service to generate a token for the more powerful service account. And suddenly you're again an owner or whatever service account you attach to that VM. So that's kind of another fun little privilege escalation track inside of GCP.
Yes, you mentioned a scenario, not the one I was thinking about, but that is a very, very catastrophic thing that could happen in the GCP transitive path that Kat likes to talk about. I was more so referring to just launching resources on behalf of the attacker in this cloud account, like crypto miners. In fact, yeah, I mean, there's multiple ways that this could go wrong. And in fact, I learned recently, I think someone mentioned that you can even use the owner primitive role in GCP to launch cloud computing instances. So imagine as an attacker, you get access to this key file, and now you can launch cloud computing instances all for free to you and to the great expense of the organization that you're attacking. So that's pretty terrifying, in addition to the privilege escalation scenario that Eric just mentioned.
Yeah, for sure. And the crypto mining thing, that's nothing new, right? We've seen that for many, many years now, where people land with, $30,000, $40,000, $50,000 cloud bills at the end of the month for compute power. And I'm not huge into crypto, so that's not where my head goes first. I'm more looking for just data. But yeah, for sure. Just the CPU cycles alone are worth something, right?
Yeah, those who know me personally know that I am not a big fan of crypto, but I am a big fan of protecting my organizations from spinning up servers to mint Doge. I'm definitely not wanting my clients to have to pay for that nonsense. Before we get back into the rest of the conversation, we have another question in the chat from Lorenzo. Lorenzo mentions, what about using Google Cloud Platform's cloud key management solutions, such as Cloud Key Management System, KMS, to deal with the problem of having secrets stored in a Terraform state file? Is that something that we could do? And even if it was possible to do that, would there be other problems associated with such an approach?
I think this is actually two different solutions. So you can encrypt bits of the Terraform state files. We've set that up before, right? Using PGP keys and whatnot. So it's not clear in the state file. So that's really, at least as far as I'm aware, the only data protection mechanism that's available for encrypting sensitive bits in the TF state file. Are you aware of any other ways to do that?
So that's one of the approaches. There also are some Terraform providers for specific resources that even build in that PGP encryption. For example, AWS IAM access keys, you can actually point that resource to a PGP key either stored locally or in keybase.io to actually perform the encryption and the decryption. But like you said, I think these are two separate problems because that's dealing with encrypting data that's actually in your configuration or a small subset of data that is returned as an attribute. There are also many, 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 many other resources you can provision in Terraform, such as, in this case, the GCP service account file. And if you create a service account and a associated key file, that's automatically going to show up in the Terraform state. So as far as I know, unless you modify that provider to automatically encrypt that data as it comes out of the GCP API, I'm not really sure what else you could do. And furthermore, even if you could use Google Cloud KMS to perform this encryption and decryption, well, now the server that's running Terraform has to have the ability to access those key files. So really, what all did you accomplish as a result of performing this layer of encryption?
Yeah. Now you can use a CMK to encrypt the underlying GCS bucket that the state file is going to be stored in. And that's not really going to fix the clear text problem inside of said state file, right? It's really just, instead of using a Google managed key to encrypt the data at rest on disk, there's a CMK, a customer managed key, basically, that is going to be encrypting the data on disk. In GCP, the permissions to use the CMK for underlying storage, I believe, are tied to a storage service account that is created at the project level when you create your very first bucket or access that service for the first time. And that's the service account that you're granting the encrypt, decrypt permissions to encrypt or decrypt the state file as you're reading it and storing it. So in the GCP world, I don't think using a CMK would have prevented my API gateway service account key from reading the state file. In the AWS world, just for a comparison, it's a little bit different because in order to read an object that's in a bucket and it's encrypted with a CMK, you actually need two permissions. You need get object on the file, and you also need the decrypt permission on the CMK as well. So in AWS, it might have helped you depending on if the service account had that decrypt permission or not, but I don't think it's something I would rely on, right, as a real mitigating control.
Yeah, at the end of the day, if your application or your server needs access to this data, you could encrypt it over and over again with XYZ type of key solution. But if you need the decrypted data, well, you need to have permissions to do the decryption. It's completely transparent to your server. So regardless of what the compliance folks will tell you, it oftentimes does not solve much to add a layer of encryption. But I think that's a great question, Lorenzo. I really appreciate that. Now, for the sake of time, let's continue on with this this attack path, because I know there's a whole lot left in the conversation.
Yeah, I mean, so we kind of stopped at that point. Usually when you get root or owner on a project, that's typically when you're going to reach out to the client and say we've got a major issue here, something that probably needs to be remediated pretty quickly. And the conversation typically shifts immediately towards, well, what can we do to fix this? That's always the first response. Like what's the right path here? And I think we've already touched on point one, which is more cloud architecture, I think, than anything else, but it's use these isolated projects or Azure subscriptions / resource groups or AWS accounts, for example, to isolate things that shouldn't be sitting next to each other, right? So as you're looking at this, what jumps out to you, Brandon, is what's the two things that really cause the most of the damage here that should be living in some other GCP project inside of the organization in some other folder?
Well, I see a Cloud SQL database at the end here, and I see the cloud storage service in here. I know we already talked a little bit about GCS buckets, but I have to imagine there's a whole lot of other data that you were able to demonstrate was extractable here.
Yeah, that was about it. I mean, the data itself, yeah, the application data with owner to the project, you can now connect to the SQL database. So there were definitely things in the database itself that the application had access to. The good news here, though, is in some cases, uh, they did have this isolated by customer in each project. So it's really kind of the customer attacking themselves in that sense. They had access to most of the database through the API, I guess is the short way of describing what was going on. So I'd say that was good. The cloud storage issue, what jumps to me is, okay, the Terraform service account and the Terraform state bucket, you got to throw that out into a different part of the organization, right? That shouldn't be commingled along with the data or the resources is actually managing and creating. So that was kind of just architecture. What jumped into my mind? I don't know. Any other?
There are so many things that went wrong in the situation. It's hard to keep track of them all. But yes, I mean, Terraform has to have a lot of permissions because it is the thing typically running in your CI/CD pipeline that needs to provision and tear down a lot of these resources. So yeah, you want to keep that as far away from your actual application resources as possible. But yeah, it's pretty terrifying what you can do once you get a set of credentials in these clouds. That leads me to a question that I think would be very valuable to the audience is, can you explain to the audience who is maybe not familiar with GCP IAM, what is the difference between what we call primitive roles to other types of IAM roles in GCP?
Oh, yeah, that's a good question to understand the answer to if you're relatively new to GCP. It's kind of like their evolution of permissions is how I like to describe it. So you've got version 0, which is, well, what are the basic things that you would want to do? So you've got owner, you've got an editor, which is kind of a read-write role, and then you got just your viewer or your reader. And those were kind of the first three roles that were inside of the GCP ecosystem to make things easy to use, kind of very simple. But as we know, simple is not always secure either. And then the evolution of their IAM permissions have gotten down to much more granular permissions, like the storage object viewer, which scopes you only to being able to read objects from GCS buckets and things like that. Those primitive roles they still exist, and they're still used actually quite often throughout their environment by default, unless you do something to stop that. So if you spin up a new function, a new app engine service, a new virtual machine, and you just click through the wizard, as we've seen just in research and whatnot, you're being opted straight into using the editor role as the service account attached to that workload, which means that VM now has full read-write on the whole project, which is not often what you really want from a least privileged perspective.
Yes, I think every time that I teach our course, and we'll talk a little bit about our courses at the end of the section for those who are interested in learning more. But every time I teach it, there's a new set of permissions that are added to the editor role. I think it went from 3,000 to 4,000. I think there's like 6,000 unique actions that can be performed by the editor role. And to my understanding, the only things that an editor cannot do is modify billing or create new IAM resources. So extremely, extremely powerful construct.
For
now,
sure.
Also, I wanted to ask a little bit about the actual cloud API authentication that started this whole issue. We're using GCP key files to authenticate to a cloud API. Is that the most appropriate way to handle that authentication? Are there better alternatives that you may think of?
Yeah. So, as we scope permissions down, I think obviously stripping as you mentioned early on, the direct access to GCS would have been good. So we could eliminate that permission. But you're right, we're still stuck with this static, long-lived key file that's going to live on this VM, and the application's using that to authenticate to the cloud provider APIs. And over the last couple of years, you've really seen pushback from the overall security community on using these long-lived keys, because those are a risk. If that gets compromised, somebody's got to go in and rotate that thing and then redeploy it out to the VM. And this isn't anything specific to GCP. Azure's got their app service or application principal, client ID and passwords. That's their version of these long-lived passwords. AWS's have been all over the news over the last decade for just, access keys that have been compromised. So they all have this concept. And over the last couple of years, the question has been, how do you get rid of that from an on-prem device, or maybe from some other cloud-hosted system like GitHub or GitLab or HashiCorp Vaults or anything like that? How do you let these two different providers trust each other and pass in some sort of a token or some sort of a assertion that says this particular principal is allowed to invoke the cloud provider's API? And you've seen a lot of work go into that. And inside of GCP, the workload identity federation concept exists. And that's a way that you can actually go in and configure trust on the GCP side to say, using an OpenID Connect provider, so an identity provider, we'll go configure a workload identity to say we trust tokens that have been signed by provider X. It could be GitHub's IDP, it could be GitLab's IDP, it could be AWS, it could be an on-prem Active Directory provider. You're configuring it over there, and you can set up a relationship that says when you get a JSON web token, for example, that's been signed by this particular identity provider, the subject tells you who that is. And then you can map that subject to say, here is the service account that you're allowed to impersonate once you get in there. With that service account impersonate call, you're getting a very short-term credential back, right? We know that GCP OAuth bearer token is going to live for, let's just say, 30 minutes. And for the next 30 minutes, you can use that token to do the same things with the API gateway you were doing before. And then the token dies and goes away, and you just stand up a new handshake the next time somebody invokes the API gateway and you need to go back and do it again. So that's the concept you're seeing kind of explode in these cloud provider APIs.
Yes, and that's certainly one solution you can implement if you're wanting to use GCP IAM to authenticate to the cloud APIs. An approach that I might take in addition to that, if I would propose this to the client, instead of taking all of those steps to get GCP IAM working properly with our API gateway, why don't we just implement a separate type of identity and access management? Why are we using Google Cloud's IAM to authenticate to this particular API that we're maintaining, this application that we're maintaining? Because to me, if you're doing that, you're kind of asking for trouble, because there's always the potential of adding more permissions to that service account. Whereas if you had some kind of arbitrary API key, where you had your own implementation of IAM at the application layer, now you don't have to worry about some infrastructure person or developer adding those kinds of permissions willy-nilly that could result in this kind of pivoting that you're describing here. So
yeah,
there are multiple ways to solve this problem for sure.
Oh gosh, yeah. Yeah, and not using that native auth, now the development team's got to implement their own version of authentication, which could be very good or very bad, right? Depending on how qualified the dev team is to do that. But yeah, you could essentially get rid of the service account altogether and pass the JSON web token straight into that API, validate the issuer, validate the audience, validate the claims, etc., and let them invoke the API. That would remove it altogether. Kind of removes the cloud ops side from the security discussion and brings in the AppSec side of things. So you're kind of trading one evil for another in some cases.
Certainly. And to be as clear as possible, because as a developer myself, I definitely don't want people to roll their own authentication from the ground up. But there are many authentication services or libraries that you can use. It's not that you have to implement this from the ground up, but perhaps have two separate systems, one for your cloud operations and one for your application operations, so that those two can never intermingle. Now, what you just described was related to how an on-premises service can invoke some cloud services, including cloud APIs and potentially things like the secrets manager or storage buckets. But one of our favorite topics has to do with authenticating cloud virtual machines to talk to these cloud services. Can you talk a little bit to how a VM in GCP could authenticate to these services? Do we need to create a hard-coded key file, or is there another way?
Yeah, it's actually easier, we'll say, because you don't need to deal with the authentication piece to the puzzle anymore. So the fact that we created a service account in GCP is enough. And as long as the actual permissions or the roles that are bound to that service account in GCP are appropriate, so we would still really just want, if that was the VM, we'd want the API gateway invoke permission, probably be the only thing, right? You don't have to deal with the authentication part. The generation of temporary credentials is baked into the virtual machine services, the App Engine services, the functions, and all of the cloud providers. They will take care of essentially bootstrapping credentials into the instance as you need them or on demand. And that's typically, I would say, 90% of the time done using what they call an instance metadata service, which we've done lots of research on and a couple of webcasts, within the last couple of years on. They're all implemented a little bit differently. But the idea is that when you make, this call to invoke a Google Cloud API and it requires Google Cloud permissions, you can talk to the metadata service and say, give me an OAuth bearer token that represents the scopes and permissions assigned to the service account that the virtual machine is running under. And then you can just pass that authorization header with the bearer token straight up to the API gateway, and boom, you're authenticated. So they remove that static credential problem for you as long as the workload is inside of the ecosystem and is running on a VM or some managed resource inside of the cloud. So you're seeing a big shift that direction because it makes things easier.
Yes, I just love talking about the instance metadata service. It's such an easy win, especially in AWS. If you are a consultant for a team that has any kind of compute in AWS, one of the easiest findings you can show, either as an architect or a penetration tester, is you have this insecure IMDS out there. This has caused catastrophic issues in the past, like in the 2019 Capital One breach. And from a remediation perspective, it is a super simple solution to fix. It's really just one command. And you'll learn about all of that nuance if you join one of us or Ken for a session of Sec 510, which we'll wrap up the session talking about a little bit. The last question that I personally have is, and this is maybe foreshadowing to our next Cloud Wars session, which it seems like that's going to be in April, on April 8th, when hopefully we'll be giving it live together from London, which I'm really excited for.
Yeah.
So we see here that there are firewall rules here. I know this is an IAM conversation, but I'm curious, were there any issues that you found with the firewall rules that were in this account that could potentially have made this attack easier? Or on the other side, are there network controls that the client could have used to prevent some of these issues?
You know, the firewall network configuration was actually very solid. So and that's not uncommon. A lot of your cloud operations folks tend to come out of kind of networking backgrounds. I think a lot of the folks building these environments out. So you could tell that they put a lot of thoughts into the firewall rules on the ingress and the egress side. And on the ingress side, it was very restrictive. The cloud APIs, the App Engine service was locked down to traffic from the API gateway. So that's a common misconfiguration I've seen, where you've got like a load balancer and API gateway forwarding to the backend App Engine service, but the App Engine service itself is just sitting out there on the internet, and you can go around the gateway or the load balancer to get to it. So they had that done very well. The VPC itself had all of the firewall logging and kind of flow logging configurations turned on. So those were good, right? So we're getting network traffic captures as much as we can in the cloud to detect, command and control and things that might originate from that App Engine container. We also had very strict ingress. They had the identity aware proxy IAP set up, and the only really administration port 22 ingress allowed to the App Engine instances was through the IAP CIDR block. So that was, pretty much in line with their best practices. Egress was restricted. I want to say the only thing they were missing was a default deny all on the egress side. And it's a subtlety inside of GCP. So the default is allow all on egress. And the only time you get firewall logs is if it hits one of your deny rules. So if you've got some deny rules and then the default is allow all, you're not going to see everything in terms of logging inside of the GCP firewall log. So typically you want that default deny all to make sure that if it is going to get blocked or not meet one of your requirements, that it shows up in an audit log. But they're pretty good, I think, on that side.
Yeah, I know that a lot of the people who work in cloud operations come from a networking background, and they're really smart about this. But man, GCP just makes it so difficult to get these things right with all of their default rules. So it's great that they worked past those deficiencies. That's excellent. So we've got about 6 minutes left. Are there any questions from the audience that we could potentially answer for you today on this subject? We'd love to hear what you have to say, and we appreciate the questions and comments we've gotten so far. I'll see if any of those questions roll in. While we're waiting for that, let's go ahead and wrap up with a little bit of a teaser / advertisement for our courseware. So Eric and I started working on a course called Sec 510 Public Cloud Security, AWS, Azure, and GCP. We started this in 2020, a little bit of research in 2019, but really got it ramped up in 2020. And we have been enjoying working on the course. We're constantly updating it. And we actually have a GX certification that came out last August. And I'm really excited to see that there are actually some job listings out there that are asking if folks have this certification. So that's an incredible honor. But let's talk just a little bit about what Sec 510 covers. It covers a lot of the topics we talked about today, juxtaposing cloud IAM and the the instance metadata service we mentioned earlier. It juxtaposes all of those topics between the three cloud providers, so you can learn about AWS, Azure, and GCP's IAM from a external source, from an unbiased source who doesn't mind telling you about the problems in AWS, Azure, and GCP. And you'll see equal coverage of these three providers across all of the different topics that we cover. That includes IAM, networking, cryptography, serverless platforms, and we'll even talk a little bit about multi-cloud integration. So if you'd like to take one of those sessions with us or take Sec 510 on demand, definitely check out our course overview on sans.org/sec510. And the certification is called the GIAC Public Cloud Security Certification, or GPCS. Now, I've also taught Eric's other course, Sec 540, Cloud Security and DevSecOps Automation. The course name has changed a few times through when I first took it in 2018, I believe, to where it is today. And there's an associated certification called the GIAC Cloud Security Automation, the GCSA. It's a great course, but I'll kick it over to Eric to talk a little bit about what that covers.
Yeah, the 540's goal really is to bridge the gap between kind of traditional operations and the world we're seeing in the cloud world today. So if you were interested or confused or wondering what the heck this CICD thing was all about, it's really looking at those workflows. And as we mentioned, kind of how tools like Terraform and CloudFormation and some of the other infrastructure as code tools out there, how they work, and talking about a lot of the risks that come along with that. And we go through a lot of application level pipelines as well. We'll look at some Java code and different tools that can be run inside of, GitHub Actions or GitLab CI/CD, and a lot of the different ways that you can automate some of the modern operation practices, and as well as lock them down from a security perspective. So that's a high level view. It's pretty action packed in terms of all the different tools that we expose you to in that class, but you'll walk away at least understanding where Brandon and I were referencing earlier in the conversation as far as how those things work.
Yes, and there's so much content between the two classes. There is a little bit of overlap, but there's no way to get that in-depth knowledge of the big three cloud providers without having 5 days of Sec 510. And if you really want to learn about the DevSecOps world and how Jenkins comes into the picture, how other solutions like that come into the picture, and how infrastructure automation works together, there's 5 days of Sec 540 as well. Just we could talk about it all day, every day for several months, probably. So there's, I think, 2 more questions in the chat, and then we're going to have to wrap up and plug our socials. A user on LinkedIn asked about the network security rules that this organization employed. If I understand correctly, they were logging everything, even the traffic that was accepted was being logged, not just the rejected traffic. But I think there may be a conflation about the allow all by default. That's what I was referring to with the default GCP rules. And they further locked that down, Eric, right? Could you recap about how they locked this down further?
Yeah, they blew away all of the pre-populated rules inside of the project, that's kind of GCP networking 101 is blow those away. But even outside of that, if you look at basically the firewall rules, there's some hidden rules that you just can't change. And so think of rule like 11,000 on the list, right? Or 65,535. The top level, lowest priority rule is to deny all ingress and allow all egress. So you're not going to see logs for what's being allowed if it hits that kind of hidden rule. So you want to make sure that all of your own rules are being enforced before it hits that one. Otherwise, you're not going to see some audit logs there. It's just kind of a nuance. So you've got to be pretty certain that you've got allow, and you need your own deny at the end in order to guarantee you're going to see everything.
And one last question before we have to wrap up for the day is Reddington mentions the possibility of just-in-time permissions for your CI/CD pipeline. Now, I've never really thought about this concept before, and I guess it plausibly makes sense in the context of a CI/CD pipeline that was administered by Google, right? Because Google has the ability to add permissions and remove permissions in that particular time frame. I don't know if that's supported in Google natively, but if you were running like a Jenkins or a TeamCity or anything like that, they have no way of adding those permissions or removing those permissions. And in fact, if they were able to do that, the attacker could just hijack that server and give themselves all of the permissions that they wanted. Is that accurate, Eric, in your experience in GCP?
Yeah, I'm not aware of a native way to do it. Sure, it can be done, just like anything else. You'd have a service account, kind of how we set up with some of our automated exercise. That's kind of the IAM policy admin. And when somebody hits approve on the pipeline, that could add the permissions, run your scripts, and then remove the permissions at the end. But like you said, if you compromise that CICD pipeline, you're still going to end up with the permissions that you want. You just have to make one extra API call to get it, and then you're off and running.
Yeah, absolutely. Now we're past the hour mark. Unfortunately, have to wrap it up there, but we really appreciate you coming to see this live stream, and it will be archived on YouTube and LinkedIn. Just wanted to say thank you again. And my name is Brandon Evans. You can find me on LinkedIn, just at Brandon Evans. You can look for Sans Brandon Evans. There's a lot of Brandon Evanses out there. I also have a Twitter, Brandon Max Evans, although I barely ever use it. You're welcome to follow both or add me as a connection. And Eric, the much more prolific Twitter user, can be found at emjohn20, as you see over here. So that's all I've got. Eric, anything before we sign off?
No, thank you for bringing me in to walk through this. It was a lot of fun.
My pleasure. I'm really looking forward to episode 2.
Sounds good. Thanks all.
Take care.